Welcome back, everybody. This is CJ, your local friendly technology addict, and you're still watching the Tech Addict's Attic. So last night I had an epiphany. I decided to start messing around with things and realized that this potentiometer here, this variable resistor, whatever you want to call it, is set pretty much all the way at the bottom at the factory. And I did dink with it a little bit. But I got to thinking, well, maybe they set it where it's supposed to be for the first startup. So I put it back. Yeah, that switch is still crap. But, as you can see, when I put that knob back where, or the potentiometer back where it belongs, I get a screen that I can read. And all it is a contrast setting. So when I had messed with it, I brought it up here. That messed it up. So now I'm going to come up here and make sure that you can see it well on the screen. Because see, this is visible for me when I'm sitting, but of course you won't be able to see anything. Alright. So FLC tester, please select. I believe that that'll be visible for both of us. Okay. So you can see that I've got a blue capacitor here. And that blue capacitor is scavenged off of a computer motherboard. It is non-polarized at roughly 300 and some odd picofarad. At least it was earlier. Let me make sure I've got it in here good. I don't. And that's something you got to deal with this is if your thing isn't in there properly, you're going to have difficulty with it. Okay, so you can see it's 2230, 2229 picofarad. I prefer pico. I want to watch it for a second, see if it hits 2232. Oh, it does. Oh, just so barely. Okay, so we'll call this 2230, all right? Let me turn that off, 2230. And I'll tell you why I'm turning it off in a moment. You don't have to. Just remember, 2230. Okay, so that's the part I just tested. My Craftsman multimeter here, that is 1999 vintage, has a setting for testing capacitance. It's one of the reasons I bought it. Okay, so this is as close as we're going to get. I should see 2.22. I don't. I see 2.44. Now, between a $7 part that's brand new, or excuse me, a $9 tester that's brand new using a bunch of parts from China that I don't trust the quality assurance on. Granted, I built it, but I'm using parts I don't know. Versus a $35 commercially built 20 years ago multimeter. I'm going to trust the multimeter first. So this is reading 2.44. This would read the equivalent of 2.22 on the same scale. So that's off by what? 10%? I'm guessing. It's too early for math for me. All right, so what I did find, let me go ahead and test this one while I'm here. This is another scavenged part. It was marked 122, so that would be 1200 picofarad. 1200 picofarad. And I get 1.30. 1300. Okay, that's within tolerances of the part, I'm sure. When I put it in here, 120 if it were on this scale, because that would round the 9 up. Actually, no, it wouldn't. It would be 119. So on this one, I get 13. On this one, I get 119. So this one seems to be reading just a little bit low consistently. Or it's possible that my commercially made product is reading a little bit high consistently. Yeah, okay, well, 100 microfarad. Can I even test this one on my meter? I don't know. No, I cannot. But can I test it on this one? Now this one is a 1000 microfarad. We have the negative on this side, and the negative here goes on the right. Oop, crap. Did not mean to do that. So, on this one, I need to turn that one off. And we want small capacitor, just for grins and giggles. 1070, 1030, 1029. We'll give it a few seconds to steady out. All right, 1025-ish. That's close enough. And if I do big capacitor, it's 973. That is a huge reason for me not to trust this thing. But I noticed something with it. This potentiometer right here is an adjustment. Now, if I go with large capacitor, it reads roughly 970. And with small capacitor, it reads roughly 1055. So 55 above, 30 below. I probably want to make this go a little bit lower, don't I? I want them to balance out, honestly. So I do have some control of the adjustment here, some control of the reading. I'm trying to think here. 30 below, 55 above. That's a difference of 85. So I want it to be about 42 and a half. I'll just say 1040 or somewhere in there. So now we are about 15 below on the one side. And 40 above. So it's actually closer now, because earlier I had a spread of 80 something, and now I've got a spread of about 50. But I don't have any instructions telling me how to use that, how to, make sure that I'm doing it right. So, I don't know. Let me go ahead and short this out. Not that there would be that much charge on it, but anyway. So I can read capacitance, and I don't really trust it because I don't know if, so looking at their website, small capacitance is 1 picofarad or picofarad to 2.2 microfarad. Okay, so pretty much any reasonable capacitor of any reasonable size that you can actually read the numbering on is probably going to be considered a large capacitor. And as I remember, I think the last rating was something like 1020. That's close enough for most electronics work. I mean, honestly, you don't ever find a schematic where they say, okay, well, we need a 1040 microfarad capacitor. No, it's always 1000. You might find 1100, 1200. You'll never find 1140, 1133, anything like that. It's always going to be hundreds of microfarads, at least in that range. So some wiggle room is expected. Now here's where we get into what I don't have a way of testing. Other than tying it to a frequency generator and sweeping across with a known capacitance, which we already know that I can't really measure. I don't have a trusted tool to measure that with. So I don't really have a known capacitance, and I don't really have a known resistance. I have a tool that I do trust for resistance, and I have multiple tools that I can use for resistance. So I could make an RC circuit to calculate the capacitance exactly, and I can make an RL circuit to calculate the inductance exactly from a trusted, though not necessarily accurate, reading of an ohm meter. But that's an awful lot of work, and that's the whole reason I bought this, is so I don't have to do that kind of work. I want to be able to just plug it in, push a button, and it tell me. Now this inductor, as I recall, I looked it up a long time ago. I've got an identical one right here. And it is marked, though I don't know if you can see it. There's a small line on the left-hand side, and then 2 rows. Top row is 100, bottom row is K. And when I looked it up online, I found that that should be 10 microhenries. I've got it written down on this one. .5 microhenries. That's pretty close. Unfortunately, I can make no change to that. Well, so maybe that is fortunate. I can't change the inductance based on that pot. So really that pot seems only to apply to the capacitor. Oh, it fell right out. Good. So for inductance, I think I can relatively trust it, even if it is a few % off. It's close enough for me to make a filter, which again is why I built this, or bought this. I wanted a tool that I could measure my components with so that I can build things. And the project that I've got in mind is an AM broadcast blocking filter for my SDR, as well as an FM broadcast band notch filter for that same SDR. I'm going to put the 2 filters in series. I'm looking for something nice and heavy metal, and this will work. One would think this would work. Okay, maybe not. Is this one of those that only tests it? No, that was live update, I thought. I'm going to leave that turned on while I pull this out. Oh yeah, that's definitely keeping a live update. Excuse me. I don't mean to clear my throat in everybody's ear. I tend to forget how well this microphone picks me up. I've got a headset mic cabled into my phone instead of that desk mic I was using. I realized, you know what, I'm doing this all wrong. I need a microphone that stays the same distance from my mouth. Come on. It's the problem with scavenged components, is they don't always fit the way you want them or expect them to. Fortunately, I got tricks. Interesting. I don't know if y'all are seeing this, but that's because of my fingers bridging something here. Yeah, so maybe we'll do that. You know, something that's $10 you don't expect to be critically sensitive to such things, but honestly, when you've got your contacts exposed the way they are on this kit, that's why most kits have enclosures. Okay. Zero inductance. Right. I believe that. Or maybe it's simply out of range. Let's see, this thing can measure inductance from 0.1 microhenries all the way up to 1 Henry. It's 1,000 microhenries. So I guess this is more than a Henry. Let me try something a little bit smaller then, shall I? Oh. Huh. Interesting. This thing's got some weird kind of error modes, I think. Again, this is a part that was scavenged, probably from a power supply. Almost 80 microhenries. So I can believe that. Doesn't mean that I do. Doesn't mean that I trust it. It could be 90 microhenries. But it's still close enough for filter work. And again, all I need is close enough. At least I get something, because when I was making these here, I was not getting the expected result out of the filter that I had built with it. So now that I've got this, I can get something that I can say, at least within a certain margin of error, is definitively what it should be. And as you can see, I got a whole bunch of these that I can play with. So I'm going to go set these over here while I talk for a moment. I said at the beginning of the video, or at least I think, it may have been one of the other takes, that I'm turning this off between tests for the most part. And it's not because you have to turn it off. When you undo the button, that should turn off the testing to the device. It's no different than having it simply like this. And you wait until you push a button. This is in its standby mode. The reason I turn it off is because I'm pushing 12 volts. Actually, if I were to read this on the multimeter, it would probably be closer to 14, because I don't really have a load on it. And of course, now I'm curious, so I'm going to go ahead and check that. Move these out of the way. Put you on volts 20. Positive in the pin. Negative on the side. Come on. Wow, no wonder. 17.48. Wow. And this is why you don't trust a wall wart. So I'm pushing 17 volts into this thing, and it's designed to take 8 to 14. The way that the linear voltage regulator works is any excess voltage gets turned into heat. In a nutshell, I mean, it's a little more complicated than that, but all that extra voltage gets turned into heat because this thing is designed to run on 5 volts. That's what that LM7805 puts out on the back side of it. So anything over 5 volts, it has to turn into heat. Now, I took this over to my bench power supply, which really I should be doing all of this on my workbench, but it's kind of cluttered right now and I don't have the room. That's one of the reasons I'm in here. Plus, I don't have a way to easily mount the camera, whereas in here I do. So this actually works for me for this kind of thing. But I ran this from 5 volts all the way up to about 12, and it seems to like anything over 6.18 volts up to whatever its maximum is, but I did not test the maximum. I wanted to see how little I needed, and it'll work reasonably well down to 6.18 or so volts. And I noticed by moving the voltage on it that it actually throws this into an error state. And it actually will say, error, please keep all switches all switches off, I think it said. And no, on. All switches on. And apparently on is the up position, which we would think of as off. But as far as the switch is concerned, apparently that is off. So I'm going to say off is normally open. However, this one, you know, I don't know. I think maybe it's an English translation error. Maybe they confused on and off. Neither here nor there. If you turn it on with one of these buttons in, it'll give you that error. But also, if you are changing the voltage, it'll give you that error. And I think that may be, in retrospect, because I didn't test it at that time, I think it may be simply I had the button in as I was turning the voltage. In fact, I know I did, because I was reading the display to see if the number changed with voltage, and what happened is I got an error, and that could be a result of changing the voltage, causing noise on the power line, causing it to think that it had been turned off and back on. If you turn it on with one of these buttons pushed in, it will give you an error state as well. Case in point, error, keep all switches on. Turn it off and it just magically goes and works. So I don't want to push more than a few, maybe about 7 volts into this thing, because any more than that and this chip's going to heat up. I don't have any kind of a heat sink on it. I don't want it to get hot in that enclosed area with no ventilation. So I want to run a lower voltage if possible. Now, looking at the website, it says that it'll take DC 5 volts or DC 8 to 14 volts or AC 7 to 10 volts. Well, I started out with 5 volts and it did not work. And I think that's because all this does is go straight into an LM7805 through a switch. So instantly you have to have a breakdown voltage above 5 volts so that the 7805 can operate. I'm wondering if this pair of contacts here marked plus and minus could be what that's for. Let's find out, shall we? I'm going to go ahead and undo the Velcro on this. I had this Velcro together so that everyone could see I wasn't doing any kind of like off-camera finagling. Not that anybody would suspect me of that. Okay. Negative on the right, positive on the left. I've got it set for 20 volts DC on my meter. And I'm reading 5.11 volts here. So I think that's what that is. If you have a known 5 volt source, you can put it to this positive and negative pin here. Right there. Or you can get 5 volts out off of that 7805 chip. Not that you would want to do that. But that's where that DC 5 volts comes from. Okay, so I know I can do that if I had a 5 volt source. Like, oh, I don't know, a USB phone charger. That would be 5 volts. Dude, that's actually tempting now. Run this off of a computer. Plug it into your laptop or something out in the field. So it looks to be fairly accurate within, you know, some Chinese QA typical allowances. For what I bought it for, which is to measure inductances, and specifically that's what I bought it for, because I don't have any other tool to measure inductance. I do have another tool for measuring capacitance, um, and I have another tool for measuring frequency. It was the inductance that I wanted. Um, for that, this will work. For that and the experience of putting the kit together and having something to play with now, this is definitely worth $9. I do want this switch to be a little bit better, but the thing is, knowing that this switch is bad and the others appear to be good, they don't appear to be giving me any issues. So I think it's just this switch. I'm not even going to worry about swapping it out, because if this one fails, I know immediately that it fails, and I know immediately I need to touch it and mess with it and get it to work right. Whereas if one of these fail, I won't know that. I'll be sitting there finagling with it, and I might think that I've got a bad component, and I won't know. So far, every one of these buttons has worked reliably except the power button. And that honestly could be, maybe when I soldered it, I took a little too long or something. I may have damaged it myself. It's a simple switch. I mean, I probably 100 for $1 off of eBay. Everything appears to work. It appears that it's at least relatively accurate. And I'm going to use it now to start measuring some coils and get a filter built. So that's my initial thoughts, my initial review on this. If I build any more of these kits, I think I said in one of my other videos, I'm planning on building a QRP kit, one of those ham radio 40-meter crystal oscillator, just a simple little schematic. And I haven't decided if I want to get one of the kits or build one on my own through breadboarding. But when I do that, I'm going to need some coils built, and this is going to come in handy. But if I build one of the kits, I'll definitely get one of those on video and give a review of them as well. So hopefully we'll have some videos coming out soon. I can't make any promises on that. It may or may not come before Christmas. Maybe next year, maybe Christmas of next year. I do not know. But stay tuned and subscribe, and you'll see if I do one. do. Well, that joke came out, so I'm going to go ahead and end this now. This is CJ, your local friendly technology addict, signing off.